Question 8 of this exercise says a horse is tied to a peg at one corner of a square-shaped grass field of one side 15 meter by means of a 5 meter long rope. Find the area of that part of the field in which the horse can graze. The increase in the grazing area if the rope were 10 meter long instead of 5 meter. So this is the area which the horse can graze, which is basically a quadrant of a circle because this angle is 90 degree as this is a square. So let's find the area of the part of the field which the horse can graze. So let's find the area. We know the formula theta divided by 360 degree multiplied by pi r square. We know the angle is 90 degree as it is a square. So it will be 90 degree divided by 360 degree multiplied by 3.14, and the length of the rope is given, that is 5 meter, which is basically the radius. And on solving this, we'll get the area as 19.625 square meter. Now in the second part it says that the length of the rope is increased to 10 meter. So when the length of the rope is increased to 10 meter, we'll take the radius as 10 instead of 5. So it will be 90 degree divided by 360 degree multiplied by 3.14 and multiplied by 10 square. And on solving this, we'll get the area as 78.5 square meter. Now this is the area we have when the radius is 5 meter. Let's take it as area 1, and this is the area we have when we have the radius 10 meter. Let's take it as area 2. Now to find the increase in grazing area, it's basically area 2 minus area 1. That is what the increase in the grazing area. So it's 78.5 minus 19.625, and on subtracting them we will get 58.875 square meter. So that is the increase in the grazing area. Question 9 of this exercise says a brooch is made with silver wire in the form of a circle with diameter 35 mm. The wire is also used in making 5 diameters which divide the circle into 10 equal sectors. We have to find the total length of the silver wire required, the area of each sector of the brooch. So the total length of wire required is basically the length of 5 diameters because there are 5 diameters plus the length of the circumference of the circle. So let's find the circumference of the circle. We know the formula to find the circumference, that is 2 pi r. Diameter is given, that is 35 mm. So radius will be 35 divided by 2 mm. So from here we can find the circumference, that is 2 into 22 by 7 multiplied by 35 by 2. So on solving this, we'll get the circumference of the circle as 110 millimeters. So the total length of the silver wire is basically the circumference, that is 110 plus 5 diameters, which means 5 into 35. And on solving this, we will get the total length of the silver wire, that is 285 mm. Now in the next part, we have to find the area of sector. And we know the formula to find the area of sector, that is theta divided by 360 degrees multiplied by pi r square. So as we can see that there are 10 sectors and all of them are equal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to find the angle subtended by one sector, it's basically 360 divided by 10, which is same as 36 degree. So the angle subtended by all the 10 sectors are 36 degrees. So let's solve this question. It will be 36 degrees divided by 360 degree multiplied by 22 by 7 and multiplied by r square, which is same as 35 by 2 square. And on solving this, we'll get the area of the sector as 385 divided by 4 mm square. So this is how we will find the area of each of the sector of the bruise, which is 385 divided by 4 square millimeter. Question 10 of this exercise says an umbrella has 8 ribs which are equally spaced. Assuming umbrella to be a flat circle of radius 45 centimeter, find the area between the two consecutive ribs of the umbrella. So these are the 8 ribs: 1, 2, 3, 4, 5, 6, 7, 8, and all of them are equally spaced. So we have to find the area between consecutive ribs. So basically we have to find this area as these two are consecutive ribs. So as there are 8 ribs that are equally spaced, let's find the angle. So it will be 360 degrees divided by 8. So on dividing 360 degree by 8, we'll get it as 45 degree. So one sector will subtend an angle of 45 degree. So this will basically be 45 degree. Now we have to find the area of the sector which is subtending an angle of 45 degree. So we know the formula to find the area of a sector, that is theta divided by 360 degree multiplied by pi r square. We have the value of theta, that is 45 degrees divided by 360 degrees multiplied by 22 by 7 and multiplied by the radius. The radius is 45 centimeter, that is given in the question. So that is a square of 45. And on solving this, we'll get the area as 22275 divided by 28 square centimeter. So we'll get the area between the two consecutive ribs of the umbrella as 22,275 divided by 28 square centimeter. Question 11 of this exercise says a car has two wipers which do not overlap. Each wiper has a blade of length 25 centimeter sweeping through an angle of 115 degrees. Find the total area cleaned at each sweep of the blades. So the area cleaned by the wiper is basically the area of a sector, and the length of the blade, which is 25 centimeter, is the radius of the sector. And we know the formula to find the area of the sector, that is theta divided by 360 degrees multiplied by pi r square. So the angle that is given is 115 degrees. So it will be 115 degree divided by 360 degrees multiplied by pi. So we'll take it as 22 by 7 into the radius, which is same as 25 square. Now on solving this, we'll get the area of the sector. Now let's find the total area that is cleaned by the wiper. So which is basically 2 times the area of the sector, as it is making 2 sectors. So it will be 2 multiplied by 158,125 divided by 252. And on solving this, we'll get it as 158,125 divided by 126 square centimeter. So that is the total area cleaned at each sweep of the blades. Question 12 of this exercise says to warn ships for underwater rocks, a lighthouse spreads a red colored light over a sector of angle 80 degree to a distance of 16.5 kilometer. Find the area of the sea over which the ships are warned. So the lighthouse basically spreads a red colored light in the form of a sector of a circle having an angle 80 degree and radius 16.5. kilometer. So we have to find the area of the sector. We know the formula to find the area of sector, that is theta divided by 360 degrees multiplied by pi r square. Theta is 80 degree divided by 360 degrees. Pi is given, that is 3.14, and the radius is also given, that is 16.5 kilometer. So on solving this, we'll get the area of the sector as 189.97 square kilometer. So that is the area of the sea over which the ships are warned. Question 13 of this exercise says a round table cover has 6 equal designs as shown in figure. If the radius of the cover is 28 centimeter, find the cost of making the designs at the rate of rupees 0.35 per square centimeter. So as it is given in the question that all the 6 designs are equal, so if we find the area of one of the design, we can simply multiply it with 6. So we can find the area of one of the design by finding the area of the sector OABC, and we can subtract the area of triangle OAC from it. We'll get the area of one of the design. Then we can simply multiply it with 6 to find the area of all the 6 designs. So let's find the area of sector. As we can see that there are 6 equal sectors. 1, 2, 3, 4, 5, 6. So it will be 360 divided by 6, which is same as 60 degree. So one of the sector will subtend an angle 60 degrees. And we also know that OA is equals to OC, that is the radius, which means angle C equals to angle A. Let's take it as x. So it will become x plus 60 degrees equal to 180 degrees. That is the sum of all the interior angle of a triangle. So from here we'll get the value of 2x as 120 degree and x as 60 degrees. So which means all the angles of this triangle OAC is 60 degree, which means it is an equilateral triangle. We know how to find the area of an equilateral triangle, that is basically root 3 divided by 4 into a square, and a is the side of the triangle. So it is root 3 divided by 4 multiplied by 28 square. The value of root 3 is given, that is 1.7. So on solving this, we'll get the area of triangle AOC as 333.2 square centimeter. Now let's find the area of sector OABC, that is theta divided by 360 degree multiplied by pi r square. So it will be 60 degree divided by 360 degree multiplied by 22 by 7, and the radius is 28. So it will be a square of 28, and from here we'll get the area of sector as 1232 divided by 3 square centimeter. Now we will get the area of segment ABCA, which is 1232 divided by 3 minus 333.2 square centimeter. So basically the area of segment ABCA is the area of one of the design, and as there are 6 designs, so we will just multiply it with 6. So we'll get the area of designs as 464.8 square centimeter. Now to find the cost, we just need to multiply 0.35 because the rate is given with 464.8, and we'll get the cost as rupees 162.68. So that is the cost of making the designs. Question 14 of this exercise says, tick the correct answer in the following. Area of a sector of angle P in degrees of a circle with radius R. We know the formula to find the area of sector, that is theta divided by 360 degrees multiplied by pi r square. So it is given in the question that the angle of the sector is P. So it will be P divided by 360 degrees multiplied by pi. The radius is capital R, so it will become R square. Now we just have to multiply it with 2 by 2. So when we multiply it with 2 by 2, it will become P divided by 360 degrees multiplied by 2, which is same as 720 degrees multiplied by 2 pi capital R square. So which means the last option, the D option, is the right option.